Let me take you to the intestinal enterocyte here. Let's consider this as the intestinal enterocytes, doctors. And on one side there is going to be lumen. On the membrane facing the lumen, this membrane is called as apical membrane of enterocyte, also called as luminal membrane of enterocyte. On the other side there is going to be blood vessels, which are nothing but villi capillaries. Villi capillaries, we studied this in the very first topic of GAT. It's nothing but the basic structure and function of GAT we knew. Inside a villus there is going to be capillaries, alright. So on the basal side we are going to find villi capillaries, and that side of cell membrane is going to be called as basal membrane. The absorption of glucose is going to be different in apical membrane as well as basal membrane, guys, and let's get to see how this absorption takes place. It all begins from basal membrane having a transporter. It's a primary active transport. It's going to pump 3 sodium out of the cell for exchange of 2 potassium. So this is going to be sodium potassium ATPase. 3 sodium is thrown out for exchange of 2 potassium, guys. When sodium is taken out of the cell, the intracellular sodium concentration keeps going down. When the cytoplasmic sodium level becomes very less, and this will favor movement of sodium from the lumen into the cell, guys. Since sodium potassium ATPase is pumping sodium out of the cell, the cytoplasmic sodium concentration decreases, which favors movement of sodium into the cell from the lumen. So while sodium moves into the cell by favor of concentration gradient, while sodium is moving into the cell in a downhill process, it's a passive transport, right? It's a downhill transport, also called as passive transport, where because the cytoplasmic sodium level is getting decreased by sodium potassium ATPase, luminal sodium is getting transported. While sodium is coming in, attached to the same transporter, glucose also enters. And this transporter, which is going to simultaneously transport sodium and glucose together from the lumen into the cytoplasm, this transporter is going to be called as sodium dependent glucose transporter type 1. I repeat, the variety is going to be very important because we do have the same kind of sodium dependent glucose transporter type 2 present in proximal convoluted tubule of nephrons. In order to differentiate that from intestinal enterocyte SGLT, you should be referring this very specifically as the SGLT1 every time you draw this diagram and you write this answer. Alright people, so this is the mechanism with which glucose is absorbed into the cell, and this type of transport is going to be secondary active transport. Going to be secondary active transport. Why it is secondary active transport? Because entry of sodium is passive, whereas entry of glucose is active. I repeat, the movement of sodium in this transporter, movement of sodium is going to be passive, guys, from high concentration to low concentration, whereas the movement of glucose is going to be active because glucose is moving from low concentration of lumen to high concentration inside the cell. Since one transport is passive and the other transport is active, we call this as secondary active transport and not primary active transport, guys. That's the way glucose enters. Once glucose enters the lumen, the exit of glucose out of the cell enters from the lumen. The exit of glucose out of the cell is by facilitated diffusion, and the transporter that takes glucose out of the cell through facilitated diffusion process and into the villi capillaries. This transport of glucose happens by this transport of glucose happens by GLUT2 transporter, and GLUT2 transporter belongs to facilitated diffusion.